All right, this is Learning Target 3 Notes, Take 2, because the first one was not closer to 7 minutes, as I told those later in class I would try. So let's see if we can do that. Add, subtract, and multiply radical binomial expressions, which basically means we're shifting from all multiplying and dividing to some adding and subtracting. There's a common theme today. Basically, if it feels like you should be able to do it, it's probably right. Your intuition is probably going to be right, in other words, because the only new concept is this concept in the box here. Just like you can add 2x plus 3x to get 5x, because they're like terms, you can add 3 square roots of 2 to 4 square roots of 2 for the same reason, because they are both square roots of 2's. So if you have 3 of them and you add 4 more, you'll have 7 square roots of 2. They're called like radicals. What makes a like radical is that it has the same index and the same radicand. So that's the only new thing. Everything else will be whatever you did in Algebra 1, pre-algebra. There'll be some distributions, some, just adding and subtracting in general. So number 1, 5 square roots of 3 plus 2 square roots of 3. They have the same index. Square roots are index 2, and the same radicand 3. So if you have 5 of them and you add 2 more, you'll have 7 square roots of 3. Number 2 is subtraction. So if you have 8 square roots of 5 and you subtract 1 square root of 5, same index, same radicand, so they're like radicals. 8 of them minus 1 of them makes, again, 7 of them, 7 square roots of 5. Number 3, cube root of 2 plus 3 cube roots of 2. Same index 3, same radicand 2, so you have 1 of them plus 3 more, you'll have a total of 4 cube roots of 2. Number 4 is a fourth root of 3 minus a cube root of 3. Since these are not the same index, it cannot be done. So, can't be done. Number 5, we have 12 square roots of 2x minus 5 square roots of 2x. Same index 2, same radicand 2x. So 12 of them minus 5 of them would make 7 of them. So 7 square roots of 2x. Number 6, we have 3 cube roots of 5a plus cube root of 5a minus 5 cube roots of 5a. You'll notice that they're all cube roots of 5a. So you have 3 of them plus 1 of them minus 5 of them. That'd make 3 plus 1, 4, minus 5. That makes negative 1 cube roots of 5a. You'll probably see that written as negative cube root of 5a. You probably won't see the 1 written in your homework answer keys. Number 7, cube root of 2 plus the 3 fourth roots of 2 can't be done for the same reason you can't do number 4. The index 3 and the index 4 are different, so they're not like terms. It's very similar to trying to add an x squared plus an x to the third. You can't do it. Or an x squared plus a y squared. You just can't do it. They're not like terms. All right, now that's the basic concept of like radicals, but your homework's going to look a little more like this example down here because it's going to involve Learning Target 1 before it even gets to Learning Target 3. So what I mean by that is the square root of 50 can be reduced using 25 times 2, and the square root of 32 can be reduced using 16 times 2. So that's Learning Target 1 things. When you reduce it, you get 5 square roots of 2 plus square root of 16, 4 square roots of 2. And now you have like radicals. 5 square roots of 2 plus 4 square roots of 2 makes 9 square roots of 2. So that's what the homework will look more like. Page 2, I believe this is the back of your notes. I can't really remember. But page 2, number 8, example 2, we switched to binomial expressions. And what probably feels right when you have 2 things in a parentheses times 2 things in a parentheses is to distribute. And that is correct. So I'm going to kind of work through this distribution a little faster. 4 times 5, 20. 4 times 4 square roots of 2 is 16 square roots of 2. And these are Learning Target 2 questions. 3 square roots of 2 times 5 would be 3 times 5, 15 square roots of 2. And 3 square roots of 2 times 4 square roots of 2 would give you 3 times 4, 12 Square root of 2 times square root of 2, square root of 4, which reduces. And the 12 times square root of 4 becomes 12 times 2, or 24. In the middle of our FOIL, we ended up with a couple of like terms. 16 square roots of 2 and 15 square roots of 2 makes 31 square roots of 2. And then last, the 20 and the 24 are like terms, so your final answer is 20 plus 24, so 44, plus 31 square roots of 2. Number 9, I would pause the video at this point. So if Miss Jackson would, if you'll pause the video, if you're watching this at home, then this is also the same video to watch at home in case you were absent. Pause the video, FOIL this yourself, see what you get, and then restart the video to see how you did. All right, 3 times 5 would give you 15. 3 times the square root of 7 would give you 3 square roots of 7. Negative square root of 7 times 5 would give you negative 5 square roots of 7. And then negative square root of 7 times positive square root of 7 would give you a negative square root of 49. Pause it if you need to think it through, but that's what you should get on your 4 distributions. We have like terms in the middle, and we have a minus square root of 49 that will reduce. So we end up with 15 minus 2 square roots of 7 minus the square root of 49, which is 7. So our 15 and our negative 7 combine to make 8 minus 2 square roots of 7. And the last problem involves multiplying conjugates, a word we should be familiar with when we were dealing with complex conjugates. Those were 2 plus 3i and 2 minus 3i. Notice it was the difference between addition and subtraction of a binomial. So here's the general form. And number 10, 5 minus 2 square root of 2, 5 minus the square root of 2, times 5 plus the square root of 2. You're going to multiply conjugates, and the same thing that happened with i's is going to happen with these radical conjugates. The outer and inner are going to cancel. When you multiply 5 times 5, you get 25. 5 times square root of 2, you get 5 square roots of 2. Negative square root of 2 times 5 gives you negative 5 square roots of 2. Notice the outer and inner are canceling. Then the last, negative square root of 2 times positive square root of 2 gives you negative square root of 4. So you end up with 25, outer and inner canceled, minus the square root of 4, so minus 2, you end up with 23. So there's the video for Learning Target 3. You have your homework on the plan sheet. If you have any questions, just mark them, and when I get back, I'll be glad to go through them with you.